Algebra, the last little piece of lesson in this mid-unit. So after this, you're going to have a quiz and then a mid-unit test. So today we're going to be comparing distributions. Let's look at these two histograms. The Science Museum has a traveling around the world exhibit. Using 3D technology, participants can make a virtual tour of cities and towns around the world. Students at Waldo High School registered with the museum to participate in a virtual tour of Kenya, visiting the capital city of Nairobi and several small towns. Before they take the tour, however, their mathematics class decided to study Kenya using demographic data from 2010 provided by the United States Census Bureau. They also obtained data for the United States from 2010 to compare two data for Kenya. The following histograms represent the age distributions of the two countries. First of all, let's talk about these histograms. I don't think it hurts to review what a histogram is and what it means. So let's see if I can make this bigger. Okay, I've already read that, so I don't really need those words anymore. We're going to do that. Cool, and you have those words in front of you. All right, there we go. So what does this mean? If we look, this bar right here represents ages from 0 to less than 5. Notice I made less than or equal and less than. So this does not include the number 5. It has to be less than 5. That's that bar right there. So if I look at the ages between 0 and less than 5, or 0 and younger than 5, about 17% of the population is that age. So which ages are represented along the horizontal axis, the x or the horizontal axis? I have from ages 0 to age 90, yeah? But it goes in groups of 5. So 0 to 5, 5 to 10, 10 to 15, and notice I've got less than or equal to and less than or equal to or less than. So this range right here, which is this one, does not include 10 years old. This one does, 10 to less than 15, etc. So those ages are represented in intervals of 5 years along the horizontal axis. Okay, this would be an etc., etc., etc. The U.S. histogram, we also have 0 to 5, and that represents, it looks like, about 6.5%. Okay, represents the people in the U.S. who are younger than 5 years old. Awesome, let's get to the work. How do the shapes of the histograms differ? We have Kenya, the first one, where we have a slow decline. And then we have the U.S., where we really don't have a decline until the end. We're pretty level off and then a decline. Okay, that's pretty significant. So Kenya, we have a slow decline. So I would say that the distribution is skewed with a tail to the right. The U.S. histogram are even for a while, and then they show a more rapid decline, right? Approximately what percent of people in Kenya are between the ages of 0 and 10 years? So I have, we already said 17% between 0 and 5, oops, and what do we have? About 15% from 5 to 10. That gives me 32% from 0 to 10. Approximately what percent of people in the United States are between the ages of 0 and 10? Let me go back and look at the graph. Looks like I have about, so 0 to 5 looks to be about 6.5% is what I said before. And then 5 to 10 looks like it's also about 6.5%. So if I add those together, I get 13%. Approximately what percent of people in Kenya are 60 years old or older? Go back and look at the graph. Okay, I want to go, so x is greater than or equal to 60. So I have from 60 to, let me start that over, I'm sorry. 65, what do I have there? About 2%. 65 to 70, that should be a percent, sorry. 65 to 70, I'm going to guess at, I don't know, 1.5%. And then we're still going. 70 to 75, about 1%. Not done yet. 75 to 80. Ooh, I don't know. 0.5%, and then I've got 80 to 85 is really the last thing I can even read there. 0.5%. So if I add all those up, yikes, 2 plus 1.5 is 3.5, 4.5, 5.5. 5.5%. That was sort of painful. I'm sorry about that. Okay, how about in the US, 16 over? So hold on a second. I did some pre-writing. All right, I'm looking at the graph now. You can look at your graph. So 60 to 65, it looks to be about 5.5. I'm going to change colors. Percent. 65 to 70, about 4%. 70 to 75, about 3%. 75 to 80, 2.5%. 80 to 85, 2%. 85 to 90, I don't know, about 1.5%. 90 to 95, about 0.5%. 95 to 100, 0.25%. There might be some in there from 100 to 105, but I think we get the gist of it. So let's add these up. I've got 5.5 plus 4 is 9.5. So here I'm 9.5, 10, 11, 12.5, 13, 14, 15, 16, 17, 18.5, 19.25. So I'm at 19.25% for the US. Okay, what does that mean? Okay, it's really interesting, right? So the population in Kenya in 2010 was approximately 41 million people. What was the approximate number of people in Kenya between the ages of 0 and 10 years? Hold on. We said that it was 32% of the population was between 0 and 10 years. We said that on question 2. So I'm going to multiply that by 41 million. And that gives me about, let's see, 32%, 13,120 people. The population of the United States in 2010 was approximately 309 million people. What is the approximate number of people in the United States between the ages of 0 and 10 years? I had to go back and look. I got 13%, 309 million, doing some multiplication here, and I get 40,170,000 people. It's a lot of people. The Waldo High School students started planning for their virtual visits of the neighborhoods in Nairobi and several towns in Kenya. Do you think they will see many teenagers? Will they see many senior citizens who are 70 or older? Explain your answer based on the histogram. If you look at the histogram, we can look at the population between 10 and 14, the percentage there. I can look at 15 to 20. Well, we do I would do less than 20 because 19 is a teenager, right? But this is less than 20. I'm going to find that percentage. Hold on a second. All right, if I add those together, I get about 15% are teenagers. So 15%, yeah, I say teenagers are a decent part of the population. You could do 15% of 41 million, and we'd probably get around 6,500 people. That's pretty good. Will they see many senior citizens who are 70 or older? So 70 or older, we calculated the percent of 60 and older to be, let's see, what was that? About 5%-ish, 5.5%. So 60, oops, did that backwards. For a population in Kenya greater than 60, we got about 5%. So greater than 70, I'm going to go back and look. I see about 2%. That's super duper small. So I don't think they're going to see many people older than 70. Okay, it's pretty unlikely. They'll probably see a lot of teenagers because there's about 6,500, but the amount of 70-year-olds and older is pretty small. Okay, let's try another graph type. A random sample of 200 people from Kenya in 2010 was discussed in previous lessons. A random sample of 200 people from the United States is also available for study. Box plots constructed using the ages of the people in these two samples are shown. Okay, we can look down and see quartile 1, the median, quartile 3, median, quartile, minimum, maximum, etc. So in these next few slides, you're going to be looking at these box plots to tell me the median, the minimum, the maximum, the quartiles, and the IQR. All of this is displayed on all of these are going to be displayed on a box plot. That's why I love box plots. They're really easy to read. I have a min, I have a quartile 1, a median, a quartile 2, a max, etc. You can do the IQR by the quartile, oh sorry, this is quartile 3. Quartile 3 minus quartile 1. We learned about box plots in a previous lesson, and they're pretty useful. If you remember, these are called outliers, and we find those by analyzing the interquartile range, multiplying it by 1.5, and either adding it to quartile 3 or subtracting it from quartile 1. Histograms don't have this information, so the min and the max aren't very clear. I don't know about quartiles, so I really like box plots. So the histogram represents the entire population of Kenya, where the box plot only represents 200 people. So I guess the histogram is extremely useful too. Adrian, a senior at Waldo High School, stated that the box plots indicate that the United States has a lot of older people compared to Kenya. Would you agree? How would you describe the difference in the ages of people in these two countries based on the above box plots? So the population in the United States has a much greater percent of people in the older age intervals. If we looked at it, we have the United States there, Kenya there. So the U.S. definitely has more people, you know, in the older range. Yes, the population of the United States has a greater percent in the older range, older age intervals. Estimate the median age of a person in Kenya and the median age of a person in the United States. So the median in Kenya and the median in the US. I'm going back to the box plots. If you remember, the median is found in the middle line, okay, of the box plots. So I need to go back and look. It looks like the median for Kenya is a little less than 20, and the median for the US is a little less than 40. So I'm going to guess at, well, slightly less than 20 and slightly less than 40 works. If you look at your paper, you should see that. Using the box plot, 20% of the people in the United States are younger than what age? How did you determine that age? So if I look at quartile 1, let's see, Q1 for the US is about, I don't know, 18. I really like exact numbers, but I would say 25% of the population is less than 18 years old. Because I would use, let's see, we've got this. This is quartile 1. So we can say that this amount of people is 25%, right? So quartile 1 is at 18, so 25% is less than 18. Using the box plot, approximately what percent of people in Kenya are younger than 18 years old? I need to go back and look. So if we look at the box plot, we're at about right there. I don't know where. That US one is not drawn to scale, and neither is that. So what I wanted to show you was, this is approximately 18. If you follow that up, that was awful. You can see that all of this is less than 18, which if I add this, let's do a different color, this piece, but that plus that piece, I've got 25% plus 25%, so 50% of the population is less than 18 years old in Kenya. And that's approximately. Could you have estimated the mean age of a person from Kenya using the box plots? No. Mean is not a data value in box plots. The mean age of people in the United States is approximately 38 years. Using the histogram, estimate the percent of people in the United States who are younger than the mean age in the United States. So I want less than 38. Pause, please. I'll be right back. If you look at the histogram for the US, it all is about right there, and then it drops down. So that's 40. All of these values are around 6.5%, and there's 8 bars there. So I just did 8 times 6.5. It's approximate. That equals 52. So you could say about 50%. Close enough, right? If we're estimating about half the population is less than 38 years. If the median age is used to describe a typical person in Kenya, what percent of people in Kenya are younger than the median age? Well, median is the half, so you would say about 50% are younger than the median age. Is the mean or median age a better description of a typical person in Kenya? Explain your answer. So 50% of the people in Kenya are less than the median age. The median is a really good indicator of the typical age because the distribution is skewed. Whenever the distribution is skewed, we shoot for the median. What is the IQR of the ages in the sample from the US? I would do Q3 minus Q1. We already said Q1 was, I think 18. Q3, what is Q3? I'm going back to look. About 58. So that gives us about 40 years. So the IQR for Kenya Q3 for Kenya is about 36, Q1 is about 7, so I get 31 years. A smaller IQR, we've done this, a smaller IQR indicates that there's less variation. More of the samples around the median age. Which you can see from looking at the histogram, right? Oh, I think that's it. Yay, you did it! Histograms are great because they show general shape. Box plots, love the 5-number summary, which I can get in my 1 variable stats in my calculator. A box plot identifies the median, minimum, maximum, and then the quartile 1 and quartile 3. IQR is quartile 3 minus quartile 1, and it is represents 50% of the data values. Median, love the median when I have skewed data or there's outliers. Good job.